Good evening, everyone. How are you? Welcome to this, our 24th Kleh Lecture series here at Boston University London Center. I'm Ken Luchin, University Provost and Chief Academic Officer at Interim. Prior to this, I was Dean of Engineering at BU for about 16 years. Felt like about 25. I'd like to give special thanks, of course, to Bill and Patty and Erin Kleh, who's here, for your family's continued support of this wonderful lecture series and so many other important initiatives at Boston University. Thank you as well to the director of our Boston University London program, Christine Goodfellow, and her talented staff at the center for this graciousness in hosting and supporting this program. Finally, welcome to our distinguished alumni and guests here with us in person and those of you that are joining by Zoom. Since its inception in 2001, the Kleh Lecture has offered members of the global BU community and our friends in London the opportunity to learn from some of our most accomplished faculty about their research, scholarship, and creative work. The vision for this annual lecture has been championed by Bill, Patty, and Erin Kleh, and is an example of their extraordinary generosity, their abiding commitment to Boston University, and their belief in the value of scholarship that deepens our understanding of the world and its great challenges. Over the years, the Kleh Lectures have spanned a range of topics with implications from advancing academic fields and with promise of translating research into scholarship and into the real-world impact. In other words, it's another example of Boston University adding exceptional value to society. A great faculty is the heart of the great research university. And the Kleh Lecture allows us to highlight just a few of the ways that our faculty create knowledge and support discoveries that improve our quality of life. This year's Kleh Lecture is no exception. Dr. Bistafros is Boston University's inaugural Associate Provost for Computing and Data Sciences and a William Farfield Warren Distinguished Professor of Computer Science in the College of Arts and Sciences. The Warren professors are our highest professorial distinction, so Ozzer is a Warren professor. For over 3 decades, Dr. Bistafros has been among the globe's leading innovators and thought leaders in the fields of computing, network security, cloud management, and privacy-preserving analytics. He's also been a leading voice as we work to better understand and manage one of the greatest and perhaps one of the most disruptive technologies advancing in our lifetime, artificial intelligence, or AI. All of us are witnessing in real time the rapid emergence of generative AI across so many aspects of daily life and its potential to transform the way we do our jobs, our ability to quickly respond to societal challenges, and of course the way we educate and the way we learn. At BU this fall, we launched a new AI task force with members of faculty from almost every school and college to specifically focusing on how to harness this technology's great potential, guiding its creative, positive use in education and research, but also how to prevent it being used in a negative way, perhaps even unintendedly. Many questions lie in our path. As just one example, how do we continue to train future generations of students to learn how to write, as opposed to just become editors? Writing, as we all know, is a way of thinking, a way of becoming more creative, and a way of even learning what you do and don't understand. We can't let that go away just because of generative AI. Dr. Bistafros has been a member of the Boston University faculty since 1991 and is past chair of our computer science department and founding director of the Hariri Institute for Computing. Over the decades, he has made seminal contributions to technologies enabling content distribution and delivery on the internet, cloud computing resource management, safety-critical software systems, and privacy-preserving big data analytics. His research has been funded by over $40 million in government and industry sponsors. And he's produced 20 PhD theses for the students, 8 patents, 2 startups, hundreds of referee papers that have been cited over 23,000 times. He's been honored with the Association for Computing Machinery's inaugural Sigmetrics Test of Time Award for work whose impact is still felt 15 years after its initial publication, and in 2010 as BU's United Methodist Scholar Teacher of the Year. 4 years ago, Dr. Bastavros was appointed to develop a brand new university-wide academic unit, the Faculty of Computing and Data Sciences. This unit would broaden our footprint in computational and data-driven research and introduce new educational pathways for all students to gain computing, data science, and AI skills, even if they were not in the STEM fields. Many of you have no doubt seen the freestanding BU Center of Computing and Data Sciences, a building that has become a centerpiece of our community and of the Boston skyline, and a living example of Boston University's leadership in innovation and in sustainability. Dr. Bastavros is building a faculty within CDS and connecting that faculty throughout all of BU that will unleash truly groundbreaking discoveries and expand capabilities in not just technology and computing, but business, science, law, public health, the humanities, the social sciences, education, and so much more. And of course, he'll be impacting how generative AI impacts all those areas. Tonight, Dr. Bastavros will take us on a virtual tour of this revolutionary technology and its impacts of all aspects of societal function. And in doing so, the research being done right now at the Computing and Data Science, at the Center for Computing and Data Sciences. And with that, it's my great pleasure to welcome to the podium this year's Kleh Family Foundation Distinguished Lecturer, Dr. Azar Bastavros.
Thank you, Ken. Thank you, Ken. Thank you for this most amazing introduction. And thank you all for being here. It's delightful to be here. It's a great honor to be here. And I'll just start by saying I'm a much better speaker, much better teacher when I'm asked questions. So please interrupt, please raise your hand. This is a topic that everybody has an opinion about, and I hope you enjoy it. I started this with a little bit of a flyover. This is our new building, the Center for Computing and Data Sciences, at the heart of the campus. If you come to Boston, maybe that's a good reason to come to Boston. Please come visit. I guarantee you the view from the 17th floor is like nothing, in Cambridge or Boston. So what I want to talk about today is I'm using the title Redefining Tomorrow, because this is precisely what I believe AI is doing right now, specifically generative AI. So there are opportunities and challenges associated with it, and I hope I'll touch on a number of those. So let's start with something that we all can agree on. Data science and AI are everywhere. They're already everywhere, okay? There is no sector of the economy, there is no profession that is not affected. And I can give examples. In the sports, the Red Sox, one of the highest salaries there is sports analytics. I can give other examples. If you think about pharmaceuticals, the COVID vaccine was designed for the first time using data science, not using wet labs, right? The design for it. Of course, we have to test it, but the design was started with data science. I don't want to go through all of them. Transportation, politics, right? All the campaigns. It's really a data science application. So how did we get there? How come we are at that stage as a society? So I want to give you a couple of slides that I present to students who come to visit BU as they shop for colleges. So this actually is a real slide I used for the inaugural CDS class of 2026. And I tell them, look, computing started 50, 60 years ago. There was a lot of advances. When you were in kindergarten, I'm talking to the students who graduate in 2026, the iPhone came about, and the internet was sort of at scale. How did we get there? There's two things I want you to remember. It's cost of computing and size of computers. So let me just get you an idea. So if you take the iPhone and want to build it in the 1970s, we can build it. Except that something that cost $100 back in the 70s would have cost $1 trillion. Just imagine, just 30 years, that's how far it has come. And more interestingly, the size of it. So you pay $1 trillion, and the best you can build is something that's 200,000 times bigger than the iPhone. Clearly, you cannot carry it, right? Because it's so small and so cheap, it means what? It means it can be in everything. Your car has so many computers. Your house has so many computers. I'm, wearing a computer. And then the question is, so what? Computers are everywhere. So what? Data. Because computers are very good at collecting data, basically. And, we can store them at an unprecedented rate. Let me just tell you that this is the 2005 cover of The Economist. And the whole article was about, the whole actually issue was about the data deluge. What are we going to do with this data? At that time, the big word was big data. How many of you have heard big data? Not as much now, right? But the big word was big data. That data deluge of 2005, it dropped in the bucket. Let me just give you some statistic. Every 60 seconds, every minute, there are 243,000 photos uploaded to Facebook. Just think about that. I'm not going to go through all of them, but think about how much data is produced. As a matter of fact, if we look at new data generated per year, 2005 doesn't even register. This is new data generated. It's expected that next year we'll have 149, now let's read this, 149 million billion bytes. How much is that? If these were stored on DVDs, the old technology for DVDs, you would have to go to the moon and down 20 times when you stack them up. This is how big this number is. It's huge. So let's look at words we use. And I'm going to start with big data. I said around 2005. What you see here are trend lines from Google searches. It's called Google Trends. You can put any term and see how much is it used by people. So you can see that around 2010, that term started just becoming very popular. But interestingly, a few years later, another term, which never existed before, became very popular, and it's data science. And literally just a couple of years later, deep learning, machine learning, and so on. And I wanted to just explain that these things are related. So first of all, what is data science? Data science is extracting knowledge from data. Data on its own has no value. It's like, the way I like to use an analogy is like, think about oil that's in the ground. It has no value. It's when you take it up and refine it that it has value. So data science is like refining, analyzing, coming out with knowledge out of data. Now, with knowledge, you can act. With knowledge, you can actually act. You can do things. And that's AI. AI is about using the knowledge you gain with data science into AI. So, great, we thought we were done. And then came generative AI. Now, let me tell you, generative AI did not exist in the language of the public a year ago. This came around Thanksgiving last year. We are almost at the first year anniversary. There's no technology that has disrupted the world, or at least there is the challenge of disruption, more than generative AI. And it's because this tool called ChatGPT was released. Now, what's the big deal? By the way, the research on this existed for 10 years. We knew about this technology. We're doing it, but we're doing it in labs. We're doing it for technology. ChatGPT, the reason it became such a big deal is because we released it for anybody to use, the public. Somebody who doesn't know even anything about computers. Well, you can use Google, you don't know anything about computers, Google search. So think about everybody who uses Google search now using this thing. And then all of a sudden they realize, oh my God, it's answering questions. It's answering questions and engaging in an interesting discussion. It's really about a conversational agent. That's actually how we think of it. It's a buddy. It just talks to you. We can ask a question. You can just ask it to give you a recipe. You can ask it this and that, and it just carries the discussion with you. I will come later to this because I promised I'm going to demystify this for you. Right? So I'll get to it. It's this box. You ask it a question, it gives you an answer. I'll come back to this later. But no talk about ChatGPT could start without using ChatGPT. So I imagine that I'm in your seat, and here's this professor coming to give us a talk. So I said, well, maybe I should ask ChatGPT, what should I expect in a lecture meant to, and I quote and unquote from the abstract of the talk. I just said, this is what the talk says. Can you tell me what's going to happen? And I went to ChatGPT. You can see I wrote that question here. And ChatGPT started, this is just a screen capture. It just started spitting this out. Here's what it will do. It started by saying, this should be a very interesting topic, a very interesting lecture. This first thing it says, okay, I hope it's right. But I was really amazed at how much of what it said I'm going to talk about. I actually was on my slides, right? So you can't tell me that this thing doesn't work. Well, if you still don't believe it, well, it just took an abstract and made it into some. How about this? Let's really put it to the test. Let's ask it the questions that we ask in standard tests. And let's see how it does. Let's start with verbal GRE score. This is to go to grad school. This is what you have to do, right? Well, by the way, there's two things here. There's the sort of this lighter teal and then the blue. This is what ChatGPT that was released in November of last year, this is where it ranked, 63rd%, that's not bad. 2 months later, ChatGPT 4.0 came about, and it scored 99%. I just want you to imagine this. SAT, writing, 87th, improved to 93rd. Now here's one that I really love, the bar exam, law school. So how many lawyers are in the room? I hope that's one of them. Well, the first one was 10th percentile, and 2 months later, it's 90th percentile. So this, if this does not sort of tell you there's something about this, because it's for the assessments we do for learning, it's doing this. And by the way, you may not know this, but it's actually generative AI, which is the technology behind ChatGPT, or ChatGPT itself, is now incorporated in tons of applications. How many of you heard of the Khan Academy? The Khan Academy is using ChatGPT. Translators and so on. To the point that the government, both in the US and the UK and elsewhere, is starting to worry about, wait a second. This thing is coming out, how do you regulate it? How do you know what it's doing? How do we make sure it doesn't hurt anyone? So this is an executive order. You can see the date. This is less than a month ago. And just a few weeks later, the UK hosted an event to literally do this. Just think about the implication. I'll come back to this point. The government actually did ask the public, hey, send us comment about what we should do with this technology. I'll come back to this. You may think, okay, it's all about GREs and so on. How about research? Research is one of the most creative things we do. And kid you not, actually, in my opinion, the biggest success of generative AI is in research. Scientific research, no less. I'm just showing you here examples, scientific. These are not magazines you can scoff at. Right? Take a look at just some of the headlines. And in this talk, I'll touch a little bit on this. So, stepping back now, I hope I showed you why data science is important and where we are. Let's define data science. And the point I want to make is there is nothing that just starts in November 2022 and somehow takes the world like that. It's not. This goes back 150 years or 100 years. It actually starts with statistics, random controlled trials. Should we use in medicine? Well, that's how we do things like statistics based on some science. But then computers were introduced. Things became very efficient. Now we can handle very large databases. You can see there's a big transformation that happens here, the cloud. Cloud computing is about building a computer like no other. A computer that is millions of times stronger than anything before. It gives us huge computational power. That actually is one reason why AI is so powerful today. Because the technology was developed back in the 80s. We knew everything about machine learning that we use today back then. It's just that it was ideas, sort of academic. Maybe you build a little, machine learning thing, but it was not working. Fast forward to 2010, cloud computing comes into the picture, data science comes to the picture, knowledge, and then comes machine learning and AI. This is the world of machine learning and AI we live in. So you'll ask the questions, why is it important or impossible for scientific approaches before data science and machine learning to make an impact? I'll tell you the reason. Remember I said there's computers everywhere. They measure a lot of information. Back when you did the 1970s medical research, you just asked the patient, put your questions, put 15 variables on a piece of paper. You enter that, and then you do your research. Today, because of all these sensors, we have so much data, and thanks to these sensors, an observation, just an observation, has a huge number of variables. I'll give you an example. Let's take cancer, prognosis. You have genomic data, you have the vital signs of the patient, you have the x-rays, and every one of these is a parameter that goes in. Sometimes you have more variables than data points you have. So try to think about this. So imagine it's a spreadsheet, Excel spreadsheet. The number of rows is the number of observations. The number of columns are the variables. Imagine a spreadsheet where you have more columns than rows. We have some applications like this. I'll give you a couple of examples. Data may be sparse. You may have a row that's missing a whole bunch of points because you didn't measure everything. It can be noisy. It can be inaccurate. As a matter of fact, it can even have errors. And I say all of this because statistics cannot deal with any of this. They just can't. The scale, the nature, so we need something else. Let me give you an example of applications where machine learning and AI will come into play. So how many of you know about drug interactions? It's bad things, right? Two drugs, you take them, they interact. How do you figure out if drugs interact? You have to do an experiment. Let's see. So, well, you do experiments, but there's different genetics. As a matter of fact, there are thousands of what's called cell lines. Think about these as representatives of different races and genetic lines. Think of it. We have thousands of those. Now, how many drugs we have? For every 2 drugs, I have to check it. We have tens of thousands of drug combinations. And then for every one of them, there's different dosage. And your response is going to be different. And you have to ask these questions. And not just that, but add to that the allergies, the age, the medical history. All of this is data we have. 10 years ago, we didn't have any of this data. Just think about it. So here's an example where you can see a lot of the measurements don't exist. So maybe for this cell line, we have this drug, this drug, this drug, but not these, right? Because we cannot do all of them. Just think about it. This matrix, you cannot do all of them. It will take you 100 years to do this. So how do we fill the empty slots here? Well, here's an example that all of you will relate to. How many of you get recommendations from Amazon or Netflix? Movie recommendations. There are millions of users. And there are hundreds of thousands of movies. And they ask you, how did you like the movie? Maybe they see you started 10 minutes later, you just stopped. Well, they actually get data from this. How many times you watch the movie? Twice, right? Now, nobody is going to watch all the movies. Yet they want to give you a recommendation. What this is, it's a big table, huge table, with a lot of empty slots. And not just that, but you also know the demography of the person watching. Geography, are they North America or London, whatnot. The daytime they watched it. All of this is data that I can learn from. So I hope I convinced you that this is a big problem. It actually happens a lot. It's the following simple problem. I have a matrix. It has missing data all over. Can I reconstruct the real matrix? So, I spare you the details, but yes, there is actually a way to do this very efficiently. It's used, I mentioned, movie ratings and drug interactions. But how many of you have used the features on your iPhone or Google phone where you say, just remove this person in the background? Right? You use it? How does it do it? It just just remove the pixels and says complete the matrix. This is matrix completion, right? So imagine, here's, I want to remove whatever is here. I don't know, just cut it out. And you give it this picture, it's going to rebuild the picture, right? How many of you have old pictures? Very low resolution. Well, that's basically, think of it, I know, I have a ton of them. It's basically a picture with missing lots of pixels. Fill it up. And the technology here is our sophomores do this. So this is not hard. It's just simple math and computer science and algorithms, right? That's what it is. Now let me give you another one. Customer segmentation or market segmentation. You want to group people so that you do analysis, sales, and so on. And how do we solve this? Again, two of the algorithm, the techniques that we teach our students entry level is something called clustering and support vector machines. Clustering is really about coloring the dots so that there are different regions. I can think about it. Support vector machines is about, can I draw a line, separate these populations? So again, these are simple algorithms. But if you think about it, you are learning from the data. Okay? So think about these as the canonical sort of stuff we knew for 20, 30 years. But here is the big one. So in the previous one, you had data and you want to understand it, right? Get knowledge out of it that way. But imagine I say, hey, play chess. That's a different challenge. Basically, we're asking the machine to develop a strategy, a winning strategy. That's very different. You can analyze the stock market data, that's analysis. But you can ask it, and what trade should I make? That's a different question. Right? It's not about giving a lot of analytics to a person to make a decision. No. It's about actually making the decision yourself. And don't suggest that this is going to be done in the stock market, but chess and Go. This has always been, humans, they always win. Well, chess, lost that war a number of years ago, and Go was the big one, because that's actually very hard, to the point that, and it won, and it learned how to play it. So how do we do this? How do we teach a machine a policy? There's actually an analogy I like to use. How do you teach your dog good behavior? Well, the dog does some action. You either reward it or punish it. If you reward it, the dog knows, this is good. You don't reward it, it's bad. And of course, these actions are in a context. Time of day, food, blah, blah, blah. And the dog actually can learn that, when I'm at home, I shouldn't do this. When I'm outside, I should do this, right? Can we do the same thing with computers? How many of you have self-driving cars? Actually, I have one. I just succumb to it and decide to get it. It's not quite self-driving. It just puts yourself on the highway and it steers, okay? How do you teach AI to do this? Well, it's the same idea. I have a bunch of actions I can take. I can steer left, right, I can brake. Right? Which one should I use now? Guess what? We can just teach it. And you say, wait a second, how do you teach it? It's going to make accidents. Sure, but maybe I don't teach it on a real car. Maybe I teach it on a simulator. Well, the same way you teach pilots to fly airplanes, you really don't put them on a plane and say, hey, let me teach you how to run, right? They do flight simulation, and they learn from it. Guess what? That's exactly how this technology is being developed. We get a simulation of, we call it a digital twin, of the real system, and we train AI against it. Every time you crash it, it's not good. You're crashing a simulation. Until it's really good, and the simulation says, now I'm going to try it for real. By the way, at BU, this is one of my students, graduated 4 years ago. And here's the trick. Drone racing is a huge, big sport right now. Well, there is one way to race. Another way is actually to teach the robot, the drone, to fly itself and win the race. So he wanted to do this for his research. And he did exactly what I just described. A simulator of the drone, very accurate. Kept training machine learning on it. And what you're going to see in the next slide is the maiden flight of a drone that's doing acrobatic things. You see it turning upside and down and so on. And the whole maneuvering, the whole strategy for doing the race was done using an AI, basic machine learning. And this is 4 or 5 years old. Okay, so now I'm going to take you even one step further. I'm going to take you from what I described so far, which is discriminative AI. AI that is used to discriminate or to decide between two things. So for example, what is discriminative AI? Well, you designed AI for a particular purpose. For example, tell me if the person in the picture is sad or happy. You have a picture, you know, the AI can figure this out. Or classify things. Is this a cat or a dog? Right? Is this cancer or not? Or just what I told you, what's the next move for playing chess? So there's a particular purpose, right? So that's called discriminative AI. Now, the reason ChatGPT touched a nerve is because it actually moved AI from bringing these applications, and thousands of those, to a new thing. So in generative AI, what you learn, the model, is literally to internalize, is for you to literally store in your brain, you here being the AI, to appreciate the relationship between things, the patterns that you see, the structure in the data, but the purpose is to generate data that is almost indistinguishable from what you fed it. It's not the same data, it's similar. So I can look at a whole bunch of pictures and say, can you now generate a picture of a male, you know, black hair with the glasses? It will do it. Now, and what it generates is actually not a real person, right? That's, you know how this is, you know, caught the world with the idea that you can fake things that look really indistinguishable. So that's generative AI, and in case you think that, you know, well, how many of you have seen the 10th Symphony of Beethoven? It's a question, by the way. How many of you have heard the 10th Symphony of Beethoven? The answer should be nobody, because he was dead before he can do it. But there were fragments of his work. So what if we submit, okay, the audio is not working. Let me see if I can make it work. All right, 1 sec. For some reason, it was on mute. Why is it muted? Oh, man. Wait 1 sec. Now. So let's go back.
Where is AI?
I know. It can't fix the PowerPoint. So what did we do? We fed all the works of Beethoven to a machine. Say, all the works, everything that he ever written. Now, take these fragments and write a symphony. It was developed. It was premiered in Berlin in 2019. You can actually now go to YouTube and see this. So this is why I said the arts is important. I'm going to now go a little bit to tell you how this is done. I promised to demystify this, so I'm actually going to tell you how it's done. And I'm going to start with the following. Everyone, imagine I have a picture of a person. Aaron's picture, right? And it's very high resolution. It's great. You can see that I can do a little transformation to introduce noise. I'll just throw a bunch of sparkles in it. So it's going to be noisier, but I know exactly what I did. I introduced noise. And I keep introducing noise until it will look like this, right? But it's something I've done. I started with a picture, and I went all the way to noise. This thing is just white noise. Now here's the interesting thing. I can reverse this. If you give me a bunch of noise, I can go back and produce Aaron's picture. Well, maybe Aaron, if I only trained it on Aaron's picture, it's going to produce Aaron, because that's the only thing you've seen. But imagine now I take all the pictures of people. And I do the same thing, but now I'm training it on how to go from a bunch of pixels that are random. Well, I start by starting with a person to go to the pixels, and I do this for hundreds of thousands of people. And now I use this to generate, because I know how to reverse it. So I give it a bunch of pixels, says, hey, you know, generate something. It's going to generate a face. Is it going to be any one of those? No. One thing I'm going to repeat later, generative AI does not store anything. It does not store the images. It learns from the images, it builds like the equivalent of a brain, and then uses that to generate the picture. I'll get back to this point. So how does it put the stuff in the brain? Say it again? Oh, yes. how does it do this? And here's the point. This was invented in 1958. At the time, AI was a big deal. People were trying to say, oh, can the machines really be intelligent? And we knew how the brain works, our brain. How does it work? We have billions and billions of neurons. A neuron is connected to another neuron with a little sort of equivalent of electric wire. And when one fires, it affects the one next to it. And everything we learned from evolution or growing up as humans is basically affecting the dependencies between one neuron and the next. So what you have is all these neurons, and they're just connected to one another. Not all neurons connected to all of them, and we learn to basically say, when this one fires, this one is very likely to fire, or has nothing to do with it. So can you imagine everything we do, like our heartbeat, how we walk, but also how we get sad or happy, is not because we remember anything. It's because this thing have learned to do this. So back then we said we should build computers that way. If we want computers to be intelligent, that's a hypothesis. And I told you, it works well problems with so computers are very good at things that humans are not good at. And humans are good in some things that computers are not good at. And this was the idea for introducing it. The problem is, it was not possible to even imagine doing it until the cloud came about. That is the point. All of a sudden, we go back to that technology and say, well, can we do it now with 100,000 computers working on it? I'll tell you, it's actually a lot of money. And this is basically all of a sudden, yes, you can. And it's all about figuring out, here's a neuron, here's another neuron. What should be the strength of that link? If it's like, for example, 100%, then if this fires, this will certainly fire. And you fire if you add up all these weights, and it's more than some threshold. That's how neurons work, and this is how you embed everything I said about learning patterns into the AI. It doesn't stop here. ChatGPT is so good, not just because you give it a bunch of pictures and say, hey, generate a picture. We can even, so remember I said something about discriminative AI? Do you remember that? AI that is used to discriminate. Now, I have now an AI that generates. What if I get them to play one another? How? So here's the game. I have the generator. It generates fake pictures. It's just something out of the blue. And now I'm going to hire a person who is an expert in differentiating between pictures. So let's take an example of an artist. Let's say Monet. I like Monet. And this person can tell you what is a Monet and what's not. I mean, I can hire a person, but I can just also train a machine to do this. Now, this generator is going to produce a picture. Without any training, it's going to be a random picture. And this guy says, this is not Monet, right? Now, the discriminator, actually, the way it works, I give the discriminator a real Monet or one of those. And I ask it which one is the correct one. At the beginning, it's always going to collect the one. But guess what? I take that feedback. Remember the dog? Remember that? So I now go back to my neural network. That's the dog now. And it's going to improve. Actually, it improves to the point that the expert makes 50% of the time it thinks the computer is the Monet. Do you see how this is very powerful? I'm using machine learning to train machine learning, if that makes sense. Right? So I'll give you an example. I'll talk later about cheating. People can write papers. ChatGPT, great, you can write a paper, but there is equal technology to discover it. Is this really written by a human? And actually, you can do it, linguistics and so on. Guess what? ChatGPT took that, and now the next version is to say that arms race is there. So I just want you to get to that's what we can do. And by the way, how many of you have done CAPTCHAs? Do you know what a CAPTCHA is? Do you think why are you doing CAPTCHAs? Oh, because we want to make sure that you're human. And what do they ask you to do? A bunch of pictures, tell you which one is this one particular. Select all images with trees. You are, my friend, a discriminator, a human discriminator. And it's using your brain cycles to train the AI. Just think about how many CAPTCHAs are done a day, right? Now let's see how discriminative AI is going to produce the Monet. So here's what we do. We take a bunch of Monets, we add noise to it to produce a photo. We know how to do this. I just showed you, right? And now I can give, so I teach, the discriminator is the one that says this is Monet versus not. And I feed a photo. Once I teach it to do that, then I can give it any photos that make it a Monet. We'll do it. Because I use now the generative having been guided and trained by an expert. That's what it is. I can do this. I have a bunch of pictures of horses. Can I make them a zebra? Sure. Here's a horse picture in a race. Make it a zebra. So you got a zebra running the Kentucky Derby. It's like, it doesn't make sense, but hey, I can do it. You go on. I have pictures in the winter where there's no foliage. You guys got what? Just let's make it summer. Right? And of course, I can do Monet, I can do Van Gogh, and Cézanne, etc. Do you get how this is working? All right. So now I promise I'm going to tell you about ChatGPT. All right, so how does it really work? So I'm going to start with the following. Imagine that we walk outside tomorrow and there's a UFO out there, something that we've never seen before. Never seen before. And everybody's going to look and say, oh, everybody's going to come up with something, an airplane, right? Because we have not seen before. In other words, look up at the sky. It's this, it's that. All of them are equally likely because actually I've never seen it before. So what if I give you this? So here's something I want you to predict. I give you the following sentence, says, finish it. Not all heroes wear, and then there's another word. Well, take all the words in the dictionary. Which one is likely? Well, you know, most of you say capes, right? You have an understanding of this context, so you'll make the probability of capes higher than pants and socks, and higher than other zeros, right? So I can use these words to predict the next word. All right? Actually, you do this all the time. How many of you, when you type and Google is suggesting a word? It's just looking at what you're typing and what's the next word. And it can do this not just to finish a sentence, but even the middle of the sentence. So, you know, Jacob something reading. Well, you know, and it's based on prior information. As a matter of fact, that's the key point. So imagine your task. Here are the same exact sentences. The sky was filled with, but the context, the previous 5 pages in the novel are talking about a horror. So you're reading the novel, you're generating a novel, and you have 4 pages talked about horror. And now I want to generate the next word. The sky was filled with, well, what words would have some probability? I don't know, bats, lightning, darkness, right? Certainly higher probability than things like hello, yes, or CRMs, and just putting some things at random here. All right, what if the first 20 pages before that was romance? Oh, it's going to be love and sunshine and happiness, and right? So context is everything. Context is everything. And the context for ChatGPT is all the text that humans have produced that's available publicly. You know, you name it. I'll give you an example of what it is. So this, by the way, what you develop, this brain thing that I showed you, is called the large language model. Some of you may have heard that term. It's basically a representation of everything you have learned. It's called the large language model because it's large and it's because about languages. ChatGPT is like that. As a matter of fact, lots of things are language, just don't think of them this way. So the input is, I analyze the word I'm going to generate after 2,048 words before that. So think about somebody who remembers 2,048 words and says, what's the next word? Yes, question?
It's 100,000 words.
Well, here we go. Well, that's ChatGPT 4. Do you see the scale? Now, we humans do this without thinking. I mean, I've been in this lecture now for 20 minutes. You have a context. If I ask you a question, you're going to answer based on that context. We do it because our brain is actually doing this. The machine will do something very similar. All right. And this is why, it passes the exam. Now, the output is simply a guess about the most likely word in the sequence, but based on having learned from that big of a context. So what's the training data for ChatGPT? Wikipedia articles in every language, news articles, books, social media, scientific publications, all that goes in. And that's what you get. And remember, like humans, we do not store data. This is why sometimes we forget things, or sometimes we recollect them in a different way. Because what we are trying to do is reproduce something that got imprinted in our brain. Generative AI is the same, right? So you would argue, how much does it cost? Given all this data, how much does it cost to do this? Well, here are some, remember this picture? And I said, oh, there's layers. How many sort of neurons that fire, that excite other neurons, etc., you know. Well, here's just ChatGPT 3, I didn't do 4. This is how many layers there are. Like 96 layers. And the number of parameters, which is the weights on these arrows, you know, in the one that actually was released in the public, it's 17.5 billion of these edges. So I have to figure out 175 billion weights based on this data. Now, how much would it take to do this? We are using this, all the technology I told you, something like reinforcement learning. How many of you heard of GPUs? Okay, you shouldn't. I hear about them a lot because when I negotiate with faculty, they want GPUs. They want computers. GPUs is sort of a computer that's just built to do very well on some of these machine learning things. A cost of one GPU is about 15K. So what my faculty comes and says, oh, I want 5 of those. Great. Maybe 10 of them. How long would it take them to train the language model? Well, one GPU, which costs 15K, would have taken you 355 years of running this thing constantly. Now, of course, we're not going to wait that long. So what did OpenAI do? Microsoft, which actually invested a lot in OpenAI, built a whole cloud for it. And with a cost of $5 million just running it, not the cost of the equipment. The cost of the equipment is a lot more than that. Just to generate the model, it took 34 days on that huge computer. 34 days, that's a lot. Now, remember when I showed you the ChatGPT talking about my lecture? Did you see how the speed with which it's writing? It's not now learning anything, it's just generating, it's spitting. So think about what goes into making the connections in your brain. That's evolution, that's long, that's very expensive. But once you have it, I mean, I am speaking like, you know, a parakeet here, I'm just. So this is important to know. And by the way, in case you think, oh, there's only one this or that, there is a large language model zoo, I call it, because like everybody and their brother is now creating a large language model. Some of them are small in size, some of them are huge, right? So these are the companies developing different large language models. And of course, your brain is going to be whatever you feed it. So maybe I want to do a large language model that's really focused on scientific computing or predicting earthquakes or you name it. Predicting earthquake may not be a huge one because, data we have is very little, but for other things it's going to be huge. Now I'm going to stop. I'm a computer scientist. I'm going to tell you why I think there's really something significant happens. So since computers were invented before my time, when you think about a computer, this is what it does. You give it a program. That's why we teach our students programming. You give it a program, has some logic. You give it data, it produces an output. Everybody agrees with this? Now we are moving into a world where we're going to change this. Actually, we don't need the program. What? Yeah, we don't need the program. And you say, how? I'll show you how. So by the way, if you get rid of the program, then I'm taking data producing output. How? Oh, because some of the data is for training. So I have a lot of data. Here is the input, here is the output. Write me a program to do this. Right? So now all of a sudden, here's the data comes in. I'll use some of it for training. And the output is going to be a large language model. But then I take this. Now this is I do for training. Once I train, I take this and stick it as the program in the traditional computer. So now humans didn't write any programs. All we did is use machine learning to learn the program, because the program is very complicated. I can never write a program for chess. Think about it. But I can put all the chess games I know and the results and develop this thing for chess. And that's the one now that's going to play the game. So at runtime, I put this in the computer, and now it's going to produce the outputs. So I mentioned how this is a paradigm shift. It's in everything. Let's take protein design. Very important. Synthetic biology is a very important field. What is a protein? So this is your 101 protein. A protein is a sequence of what's called amino acids, which is like large molecules. But it's a sequence. Oh, wait a second. Okay. But it's interesting because these amino acids don't stay in like this. If you spread them like this, good. You let them go, they curl in an interesting way. And then, so they curl like this, and then you put a bunch of them together, it even becomes bigger. So can you agree that if I think of a protein as a word, it's a bunch of amino acids, right? Then a sentence is going to be how this thing just folds, becomes a sentence, and then a paragraph, and then an essay. So that's the analogy. Of course, that's what I'm trying to say is there is a language. It's just that you can do all the biology in your lifetime. You can read all the papers in the world. You as a human will not be able to speak the language of biology. Can we learn the language of biology and then ask it to generate things? And the answer is, so this is what I just said, proteins can be used as language, just like English. Have words, amino acids, put them together to make a protein. Now, the amino acid appears in sequences that are not random. It's not random, right? And they have functions, so we know this protein does this. Now, it's impossible for us humans to gain fluency in this language, but we can actually do it with machines. Well, now I go to the machine and says, design a protein that looks like this. Protein folding was one of the biggest problems for like 20 years in biology, which is what is the shape of that end result? Because when you develop a vaccine, let's say, I know what is it that you're trying to attack, and you want to design something that just hooks in it the right way. And we're trying to have basically PhDs to try to guess these things at huge costs, because you have to try and they don't work. Imagine now a machine learning that says, oh, okay, based on everything I know, that's the AI. Here is the top candidates for what you want. A human may come with 100, maybe one will work. And the machine learning comes up with like 3, and the first one works. In case this is a paper published earlier in 2023. It's basically how large language models generate functional protein. A functional protein is a protein that has a function. It's like a protein that's going to cure this, right? So I know what I want, like a design, build it. And you can read the paper. This is in Nature Biotechnology. So I stop here and then say, you've been talking about just telling us about all this, but what is BU to do with it? So I'll go through a quick set of research related to this that we do at BU. Hopefully I have time. I think I do. So the first one is machine learning in systems biology. So let me tell you how, we understand biology. A cell has, a bunch of stuff I don't even know myself, but when you disrupt part of it, other parts get disrupted. And the way to find out how cells react is literally to poke it. And you do that by going to BU. We have a very nice lab. It's where you literally take the cell, poke it. Maybe I put some dye, like a color dye. And then some parts will absorb this, others will not. And I look at the microscope. It says, now I see. When I do this, this happens. And I do it with basically imaging. And I have people do that. Okay, that sounds good. What's the problem? The problem is each one of these measurements is an individual observation, and each one of these is very expensive. It's a lab. It's a wet lab. And if you need to do, so there are actually experiments that we knew that we needed to do that we could not do, because when you do the math, it will take 100 years. because the number of things you have to try to understand. We know how to discover the relationships. It's just the way we're doing it was impossible. So here's what it is. I want to do n perturbations because I want to learn about this big matrix. So I need n samples that I analyze. Well, good luck. That's never going to happen. So we have a faculty who started using machine learning to do this. And his idea was very clever. So here's the idea. The existing way to do this, the way you teach students how to do this, is to say, here's the machine. The machine, you have to do one thing and see the output. And he says, the machine is not going to bite me if I do two things at the same time. As a matter of fact, he said, I'll do maybe 5 things at the same time. So he actually does n but every one of these is affecting multiple parts of the protein. Now, if you look at it with your eyes, it's a mess. It's like basically a hodgepodge of colors, right? But if you do maybe 1,000 of those, you can ask machine learning to invert it. Now, go back, give me the picture if I only try this one thing. Do you understand? So I'm going to mix it up. I can't understand it. But I have the model that can invert it. It says, imagine that I did every one of these dice separately. What would be the result? Yeah, this is the work of Brian Cleary. Just hired a year and a half ago. He's in the Faculty of Computing and Data Sciences. We stole him from, he did a computational biology degree at MIT, moved to the, what's the name of the institute? The Broad Institute, and we got him from here. And what I show you is, instead of doing 20,000 experiments, which is not doable, no pharmaceutical will pay that much money. He has a paper that says, oh, I can do this in 15, 20. Just think about this. That's 2 orders of magnitude improvement. It's not just the improvement, cost and time. The companies will never try something that takes that long. I cannot make money out of it, but this can. By the way, he has another paper related. How many of you know pool testing for COVID? Pool testing for COVID. What's the big idea? Well, instead of doing a test for you and a test for you and a test for you, that's a lot of tests. It's expensive. How about if I group 20 of you? It says, oh, go all spit in this thing and I'm going to analyze it. That's called pool testing. And there is a way to go back from this to who has COVID, if any. That actually saved the day. You can do this in schools and so on. He wrote the paper. So here's the question. How many should I pool together? 20, 30, 50, 100, 1,000? Well, the more you pool, the less accurate. So there's a nice balance. Too few, then you're back to being very expensive. Figuring out that, well, that's a data science problem. He wrote a paper on this, the paper on COVID. Here's another faculty favorite of mine that I'll talk about their research. By the way, my job is great because I get to talk about other people's work, which is fantastic. So a big problem in social sciences is about understanding human decision making. Like, why do we make this decision? Now, of course, this is important because if you're a marketer, wait a second, I can, right? If I'm on the stock market doing exchanges, if I understand how people react, I can win big. So, and this is the domain of psychology. So psychologists, this is actually think about is we do some things rationally, we do some things irrationally. Can we understand human decision making? So for example, should I go to the theater or should I watch it on Netflix? And my brain is thinking, oh, there's a 2% chance of getting COVID from there. And I make a call. I decide to take that risk or not. Right? That's taking a risk and I make a decision. I want to understand this. Now, psychologists do this by literally paying people to do the experiment. So how many people you can pay? 100? 1,000? Actually, most social sciences is hundreds. Guess what? Every day, people make decisions all the time because you click on things on YouTube. You're doing this and this and that. Why not use data from there to learn how people make decisions? We have all the data. We know who they are. We know where they come from. As a matter of fact, we have a faculty also hired, just started this September. He's Josh Peterson, Stanford PhD in psychology, not computer scientist, who's using this to transform psychology. And he's very good at machine learning because that's why he can do it. And here is the paper. He was using large-scale experiments in machine learning to discover theories of human decision-making. How good is his discoveries? Well, let me put it this way. he took the problem that somebody got a Nobel Prize on, and their model, which is developed because they thought about it, has some prediction index. Like, it's successful 85% of the time. It says, well, 85 is better than 50%. That's great. You go to the technique that Josh used, it's 4+ times more accurate. Here's another way to think about it. Here is the best human theory. This is developing a theory for how we think. The best human theory has some prediction error. The lower, the better. Here's the one that humans have developed over the years, the best. And here's what happens when you use big data. As a matter of fact, using only 10% of the data he has, he matched it, and then below that you can see how well it does. The last thing I want to talk about, because I'm an educator, is some other faculty is doing it, which is something I hope there will be lots of questions, which is, what do we do with ChatGPT in a classroom? Now, I'm going to start by saying, and we can disagree, banning it is not the solution. As a matter of fact, it's a challenge to how we teach. We have to up our game, right? It's not about ban it. Ban it, that's sort of knee-jerk reaction. How can you teach given that you have ChatGPT? That's an important point. So let me show you. This is a programming class. So this is a course called Python for Data Science. It's the first programming class we have, and it's taught by Kevin Gold. Great teacher. And he has a homework assignment, and he showed, he uploads the homework assignment and asks a question. Well, there's a part of the homework assignment. Write this. Here's the code. It's generated, and it's correct. It's generated by ChatGPT. Students can do the same. Now, because he's smart and he knows he didn't teach students some things, it actually used something he didn't teach. It's correct. He says, so maybe the teacher can figure out, wait, I didn't teach that. But maybe the students have done this back in high school, and maybe they knew it, so I don't know. So his approach is the following. Why are we wasting our time worrying about who's cheating? Why don't we say, use it, but don't use ChatGPT as is? So the idea he had, which is beautiful, is Socratic ChatGPT. Imagine I build a ChatGPT that answers every question with a question. That's called the Socratic methods. That's the best teachers do this. So when a student comes to my office hours and they ask the same problem on a homework assignment, I don't solve it. ChatGPT will just spit it out, right? No, I sit with the students and well, did you remember this? Did you do that? What am I doing? I'm engaging the students in conversation, or I'm asking a question. And every step of the way, they get closer, hopefully. And eventually, okay, they figure it out, or they're maybe 95% there. At that point, I can give them the answer. They got it. That's how we teach. So he said, rather than banning this, I'm going to add to it a layer that makes it answer every question with a question. How you say this works, I'll give you, this is how it works. Here's the analogy. Here's ChatGPT, the good old ChatGPT. And he developed this tutor that he make available to his class. And he said, you use this. If you use ChatGPT, you can, but you're not going to learn anything. And you're going to fail in the exam. So here's a tool to help you. It's ChatGPT, except it's not going to really answer your question. It's going to guide you to the question. And he called it something, and the students can just fire it up. Now, when the student fires it up, what they don't know is that behind the scene, Kevin Gold, tells ChatGPT the following. You are a helpful teaching assistant in a data science course. Your primary goal is to help the student learn. This is the homework the student is talking about, and then he sticks the homework in it. That goes up there. It's as if the student wrote that. Next. Well, the students wrote their answer, the question. It comes to their software. And then here's what it says. For this query, answer with a single question that you haven't asked before. It would be very boring if you keep asking me the same question as a student, right? I have to go around without directly giving away the problem. And if you can't, quit. So don't give them the answer. And now, so this is still something that it's a prompt, I give it, but I stick the student question at that point because I don't know what they're going to ask. The answer comes up, okay, this is the answer. How do you iterate over a list in Python? It's not really the question you asked. But the students will answer, and through that conversation, they get to the answer. Now, how do we know it works? Because, by the way, this is an example. This is a real example. Students ask, what's the answer to 1A? And here's the answer. I'm sorry, but I wouldn't be appropriate for me to give you the answer. Have you tried blah, blah, blah? And then this is actually where it's, have you tried using a loop? This is iterate. How do I iterate? Well, in Python, you can use a for loop, blah, 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 blah. And then, do you know, remember, I always have to end with a question. Do you know how to set up a loop to iterate through tuples in Python? You better know it. It was the last homework assignment. And then the students will keep going. Actually, he discovered. Now, how do we know this? Because, of course, part of using this, we have the data, and he, the instructor, can look at it and can see, am I teaching well? How are students progressing? And here's a surprise to him. The students are using it for things that are not directly related to the homework. So, for example, why in Python does the answer to 5.4 have so many decimal places? Like, it's 5.999999. Well, you know, why is it not 6? Which is probably the right answer. Well, guess what? I can answer that too. And it's had to do with arithmetic and how computers work. So now the tutor says something. Oh, this is because of this and that. And the student is engaging in learning about something that's basically not part of the homework. Isn't that great? It's like a student comes to my office, and then we start talking about something unrelated. That's great. I told you that he has data. This is the first semester he's using this in. He asked us about it, and I said, great. So, you know, he developed these slides halfway through the semester. Less than halfway through the semester, you engage in the bot over 8,000 queries. So they're using it. Now, you know, these are computers. There's no reason to thank anybody. But the students thank them. They even write something like, adorable. Do you see the point? Now, the feedback, I mentioned this. The instructor gets the feedback. Better yet, so far this is where we are. Now, better yet, here's what we can do. Better yet, we can tailor the learning experience to each student. You know why? Because there's context now. I know what you did in homework 1. Now, when I help you in 2, I'll help you differently. Because I know the answer. I know we went through this before. I can even refer to it. So imagine now everyone has their own tutor in a classroom. This probably you'll do it next semester. He has this. Okay. Even better, I can use stuff from high school. I mean, so this is not just a course, homework 1, homework 2. It could be all the courses you take, because I know, oh, you're weak in algorithms, or you know, I can help you with that. So the bottom line here, I love this work because the human connection, meaning, and all that, that's what an instructor should worry about. But executing this, let the AI do it. It's okay. It's a tool. Okay, so now I have to go a little faster. I think I have another 10 minutes. The elephant in the room is privacy. You may have worried about that. So all these problems are really problems where we want to get knowledge. We want to get machine learning by connecting, for example, patient data with contact for COVID. Economics. I want to connect data from the Department of Education with IRS, because I want to see are outcomes from education worth it. IRS tells me the tax, how much you paid in taxes. I know your income 20 years after you graduate from BU. How is that comparing to somebody 20 years out of NYU? We have the data, and we can do it, except we have rules against that. The government does not allow IRS to share data with anybody else. Here is one. You know, this is the Department of Children and Families in the state of Massachusetts. They have data about the kids who are in trouble and how they intervene. But we also have the schools in which the kids go. And we can look at things like absenteeism and so on. If we connect these two, we may actually come up with the best treatment, intervention for a student who is in trouble. Instead of saying, just flip a coin, put them in this program versus that program, we can direct this to it. Okay, you don't agree?
Yeah, I'm sorry. I'm sitting here being very quiet. There are a lot of assumptions that are being made. I appreciate the technology and how great it is and the correlations, but there are assumptions that are being made by a certain group of people.
I'll get to that.
Affect. So the ethics in this.
I'll get to that, I promise.
Yeah.
You know, ChatGPT gave me the outline of my lecture, and there was a section about ethics. So. But I want you to see how we traditionally think about the problem. Collect data, we secure it because I want to leak. We access the data and we use it. What if we remove this? Can you? Can you actually remove access? Can you derive knowledge without even looking at the data? You say, how you do that? Well, the data is encrypted. Can you compute on encrypted data? The answer is yes, we have a group of us who do this. So you have an algorithm that can figure out from a bunch of data some knowledge. Is there a way to get that knowledge when the data itself is encrypted? It's not, nobody can understand it. The answer is yes. As a matter of fact, this is one of my works back a number of years ago, where we did this for gender pay equity. We take all the companies will never share their payroll, never. But we can use the payroll to actually give you very accurate, granular about, African American women working as a programmer versus this and this. And can do that, but no company would will never do it. We convince them to keep the data where it is. It's encrypted, but we can do the analysis on top of it. You can actually go get this report. Every year is produced right now, and here's lots of other applications. So now I'm going to get closer to the ethics, which is actually an area of algorithmic oddity. The problem with this machine learning AI is like a black box. I have no idea what's in it. So let's talk about maybe the pluses. Maybe it's fair because I don't know, maybe it's fairer than humans. Humans are biased. Who said that judges are not biased? They're biased. So maybe if it's a computer, it's less biased. Okay, that probably is a plus. Maybe it's efficient and scalable. So I don't need to have a judge in everyone. Maybe. But here's the problem. You can inherit biases from training the data, which is a problem. Not just that's worse. The person developing these machine learning may actually embed their own biases. Now this is like intentional. That's a problem. That's a big problem. So a bunch of us at BU are really worried about this problem. It's like, how do we audit AI? The IRS will audit you if you cheat. How can I audit AI? This is an area of research that we're very interested in doing it. And it's really about accountability. So there is, first of all, can you explain your answer? Are you taking care of privacy? Are you fair or biased? Right? Are you making assumptions? I'll get to that in a second. Safety. And this is something that we argue that the government has to start thinking about, is to regulate this technology by taking this into application. I'll say there's faculty who are doing this. Who are they? Well, first of all, I'll talk about auditing. How do you audit? Because you cannot see the code. You can't understand it even. So the way to do it, how many of you use YouTube? And let's say you Google the Gaza conflict, PBS. Trustworthy, you go there. And Google gives you a bunch of things on the right. He says, hey, try to go there. This is a really expanded. 6 clicks later, it's giving me basically an extremist group video or something that's very biased. Why did it take? I asked about PBS. I didn't know about NPR. I didn't ask about this, but somehow I got dragged into this. Why? The machine learning got me there. That's not an acceptable behavior. I did not ask you to do this. That's an example, and we have faculty thinking about this, which is, can we audit the behavior so that we can infer there's something wrong? We don't know how to fix it, but we'll put you accountable for it. You have done this. This is, why are you putting that stuff in front of the user? By the way, here's another one. I told you there's a lot of large language models. Guess what? There's 300,000 versions of these now out there, just descendants of large language models from OpenAI. Which one do you pick for your business? Which one? You need auditing in order to basically drive test them. So what are your standards? What is important for you? Which one will be better? It's like comparison shopping. So this is another example of this. And here is a set of faculty. Half of them are computer scientists and engineers, and half of them are lawyers. Remember I told you the government asked for feedback? They wrote one of the most comprehensive paper of this, and here is what they recommended. Ethics. I'll get to that in a second. We teach that in class. It's very important that when you develop, you actually should also say what the risks are. So even if you use it, before you use it, tell me what the risks are. And if you don't know what the risks, then you shouldn't use it, right? So these are some of the recommendations. You can read the white paper. But actually, I want to use, Stacy Dogan is a lawyer. Okay. This is a quote from an article written about this. And I don't want to read the whole thing, but she talks about CDS, how difficult it is our collaboration reinforce the conviction of the faculty of computing and data sciences, because it gets lawyer to talk to ethicists, to social scientists, to certainly the computer scientists. So now I'm going to flip and talk about what she's talking about, CDS. What is that? So this is self-promotion. So I'll have to tell you a little bit about it. And just something to your old BU fans, BU has been invested in computing for a long time. You may not know this, but one of the very first labs on cognitive neural networks, which is basically a predecessor to everything I talked about today, started at BU, Steven Grossberg. He's now retired. But fast forward, one of the big decisions is building the Hariri Institute, which is about interdisciplinary research. Fast forward says, well, we need to hire data scientists who are not really necessarily computer scientists, like somebody doing this work or that work. And really, the two big decisions were the creation of this new faculty and making a statement about the building. So the first one is the Center for Computing and Data Sciences. If you haven't been there, you saw some video of that before. But I just want to say that this is a statement, because the university does not put a building like this at that cost, at the absolute center of the campus, unless it wants to say, hey, this technology is changing everything, and we want to educate and do research really around this. More interesting than the building is what's inside the building. I like to say that CDS is like taking ivory tower and making them a public square, making people talk to one another. And it's really about democratizing access to this new technology. So students who never thought or don't want to be software engineers, they should be able to be data scientists, right? Students who were afraid or hated calculus in high school, they could be the best data scientists. Why not? Because we're going to teach it differently. We're not going to teach it by having these gateway courses. I have to take these 5 math courses to do anything that's useful. No, we develop a new curriculum because we can do that. And by the numbers, this was launched in 2019. A lot of great things to brag about. I'm not going to go through all the numbers, but the most important one was hiring faculty who are different. I talked about 2 of them, Brian Cleary and Josh Peterson, but there's equally very interesting set of faculty. Ngozi Okedegbe, she's in law school. She wrote the book, say, The Democratizing Power of Algorithms, question mark. A question mark. She's a lawyer. She's criticizing, she's working, she teaches our ethics class. Now, who else is there? Take Kira Goldner. She's at the intersection of economics and data science and AI, and so on. I can go all of them. We also have an amazing teaching staff. Kevin, I mentioned his work, Kevin Gold. He's a teaching faculty. He's a professor of the practice. But he came to CDS. We stole him from Northeastern precisely because what we wanted to do in CDS. It's not about computer science anymore. It's bigger than that. Leonidas Kontothanasis. He's independently wealthy, not because of anything. He was a PhD student at Rochester, because he just worked in every company that became a big deal before it went public. He has a foundation now. And his last act is to be a faculty in CDS. Came out of spending a ton of time at Google. Same thing with Langdon White. Lisa worked in the Netherlands in the Department of Education. So these faculty are joined by also faculty from across the board, from BU. So they are, from how many? 24 departments in 11 schools. This is really the footprint of computing and data sciences at BU. The way to think about it is this new academic unit we created cross-cuts everything else. So it's like a school, but it's not sitting vertical. It's sitting horizontal. It wants to connect sociology with computing, also connect humanities even with that. Another thing, and thanks to Provost Lucian for this, we are on a second year of what we call an AI cluster hiring initiative. Now, typically in a university, every department will get 1 or 2 lines and they search. But if we believe that AI is so important, then lots of departments should hire an AI. But instead of doing it piecemeal like this, how about we advertise it as a cluster hire, a group together? And this year, we have this. Let's give you the numbers here. It's a university-wide initiative led by us in partnership with 6 schools are part of this, not just CDS, with 9 departments part of it, including philosophy, which potentially can hire somebody working at the AI and ethics connection. By the way, last year, these are the folks we hired, because this is the second year of doing it. We're going to do it at least for 3 years. Academic program in CDS, we have an undergraduate major, we have an undergraduate minor, we have a PhD in computing and data sciences, and we have graduate and professional degrees online, et cetera. That's all coming. You'll argue, why do you need another degree? Well, maybe I explained a little bit for them. How about PhDs? You need to prepare PhD students differently because they have to work across disciplines. Somebody who's going to do data science for cancer, they have to know something about medical. You cannot prepare them by putting them in a computer science department, and you cannot prepare them, put them in medical school. It's a different breed. It's truly interdisciplinary. This is why we have this. So how popular are these programs? Here's the undergraduate teaching. So we teach a lot of students. These are the students in CDS. These are majoring in data science. And look at the students who are not in CDS. They take these courses because they realize this is important. It's not a requirement. They do it because it's important. From every part of the university, and you can see the growth. Here's fall, spring, fall, spring. This is the last spring data. Students minor in data science from all over. Why? Because they're smart. Hey, if I minor in this and I'm doing Earth and Environment, I'll get a job. That's great. Not just that, but some of them actually decide to jump ship. Says, you know, I started in political science, but I'm going to do data science because I can be a political scientist if I do data science, but not the other way around. Right? And it's all powered by our belief in putting the students front and center through a program we have called BU Spark. And BU Spark is really about experiential learning, which is when you teach in a university, you should bring real world problem for the students to work on. And so, you know, again, I'm not going to go through a lot of details, but it engages students from their first day at BU, creates community, connects them with students from different units through a bunch of programs, like things like code jams, micro jams, just a little bit like hackathons, but very small hackathons for somebody who's just starting. Connect them with problems. And then we have courses called practicums, where we take problems sourced from places like the City of Boston, the Museum of Science, which are data science projects. And we embed them in the course where they can basically sink their teeth into them. Students get so excited because I'm working on a real problem. One of my favorite examples is a museum, the Harvard Museum has leaves that they collected over like 300 years. They're all dried and handwritten. This was collected from here, and it's all on a piece of paper. Of course, they want to digitize all of this. So yeah, you do natural language processing, maybe to appreciate the words, but also they want to develop algorithm that can learn and label the leaves automatically. They're on their third year, and they keep building projects on top of it. These are undergraduate students. Here's the point I wanted to make. Remember when I talked about the algorithms at the beginning, it says our sophomores can do this. Yes, they can, right? But you really have to educate them differently because it's not really about the computer, it's about what it can do. And finally, students can bring their own ideas to do innovations. How successful this program is, I just let the numbers speak. It's just unbelievable how much they do. And let me finish with my favorite slide. Not quite, there's only one more. Remember ChatGPT started November 2022. That's the end of the semester, can't do anything about it. But we have a next semester. And everybody says, oh, what are we going to do? This thing is going to cheat, blah, blah, blah. We have a course, it's called Data, Society, and Ethics. Who teaches it? This fellow. He is a professor of ethics in our School of Theology. But he happens to be a very strong computational scientist as well, where he does simulations of human behavior, you know, religions, all these things. And he saw this coming out. Now he teaches that class. It's a class on data, society, and ethics. What do you think he's not going to teach programming. He teaches like we teach in business school. It's a case study. And he does scrap his first case study. He says the first case study is you class, students, there's 30 of them. You are going to write a policy for how the university should deal with ChatGPT so that you get educated better. So the student wrote the code of conduct. Now, there's iteration, discussion, they fought, and they came up with a beautiful policy to the point that we faculty looked at it and says, you know, this is worth adopting. We changed it to a few places, and we actually became the first academic unit to the point that, you know, we get coverage in the news, and you can scan this, get all the news articles written about that one exercise in a course. Now, the reason I mention this, and it's important, it's really important to involve those affected by machine learning in the discussion about how to develop it. So you want to use machine learning for, I don't know, putting police on the street? Who's affected by this? It's the population that's going to be policed. They have to be part of the design team in a way. And that's actually an approach increasingly in computer science we're using, or data sciences, which is using human factors, or humans, where the human is actually in the middle of this, and that's important. And by the way, Provost Lucien mentioned this, we are taking this in university-wide. So the university actually, thanks to Provost Lucien, launched this AI task force, and here is the goal. It's representation from across the university. And with that, I'll finish with the one question that students ask all the time. So, is AI a friend or a foe? So here's the quote, you can quote me on this. Your job, your business, your research, ... is not going to be lost to AI. Wrong. And we can discuss this at length. It's going to be lost to someone who knows how to work with AI. I do believe that AI and humans will work together. It's just a tool. And I can argue that, despite everything I showed, AI is not creative. It's not creative. The algorithms that Josh Peterson came up with, the algorithms that Brian Cleary came up with, AI could not have come up with it, because there's nothing in its knowledge to do this. So creativity is still there, it's just that it has to be done with humans as co-pilots with AI. So with that, I just want to leave to taste what computing and data science is. It's not this remote thing. All right, with that, it's maybe a little long. I just want to get to one place where I think you'll like it. Hosting lots of this is the top of floor of 17. You know, you can look down, quote unquote down, at MIT and Harvard, or maybe another way to say it, they can look up to us because we're on the other side. This is the top floor again. It's called the Jenga building. How many of you have heard that term because of the shape? Okay, and of course we have to have Jenga nights, right, to play the Jenga thing. Students, I talked about drones. Well, students are playing with drones. And you can see the students flying the drones outside. Okay, that's what it looks like. Good. Is that allowed? It is allowed for specific sizes. You can do it, yes. You don't need to get permission, but if you're going to go above the turnpike or something, yes. So it depends on where. NBC covered us. There is a very important store on the first floor. It's called Saxby's. Basically, melted cheese sandwiches and mac and cheese. Very popular among students. We sent students on symposia. Tech to Government, that's an interesting program we have. This is Abuse Park. I mentioned about how popular it is with students. These are the new faculty we welcomed. And we're very proud of being, pet friendly. Yeah, you come to my floor, it's like 4 pets, and adorable. But Jenga night, so they wanted to get Jenga night. Yeah, that's what happens when you do Jengas. But we also have, let's see, yoga nights. So that same space you saw, guess what? We have students do yoga in it. So let me stop here and take questions.
Come on ahead. Folks, that was absolutely spectacular. I want to again thank Bill and Patty and Aaron Kleh for sponsoring this great lecture, and all the alumni and friends. And parents and people online to attend and listen. And we do have about negative 30 minutes for questions. Just kidding. But I don't know who's keeping track of any questions that might be online.
I have nothing yet.
Okay, so questions from the audience.
Please, yes.
Thank you. It was a great lecture, and I've learned myself a lot of things. One point that you made during the lecture toward the end was around creativity, right? So for me, one thing which I'm trying to understand is, how does AI deal with the unknown unknown?
As what?
Unknown unknown.
Unknown unknowns. It doesn't. I think that's where the human piece is. This is where the human touch is. And you have to take risks, right? So let me give you another.
Can I just?
Yeah, please.
It will always give you an answer.
Correct. It will, well, the good ones will not, actually. If you try, right now they're starting to be careful about that.
But I think that's kind of the core of, it doesn't really know.
It doesn't know what it doesn't know.
Something anyway,
yes,
right?
It doesn't know what it doesn't know. Correct.
Because to me, it looks like it's an intelligent way of data mining, where you're giving all this data and you create the large language model and you come up with solutions which are more structured than the human thinking, right? But when you look at the advancement of humanity or how we've evolved, an important part is how we've dealt with the unknown unknowns. And to me, that is what I kind of find it, I haven't seen anything on it, so.
And remember what I said at the end, it's working with AI. It's AI on its own, in my opinion, it's not gonna cut it. Let me give you an example. Lawyers started to use this, and one lawyer was not very smart, decided to use it and submit to the judge a ChatGPT case, right? Because it can do this, it can search. And the judge reads it, and the judge sort of halfway through said, this doesn't make any sense. Looked at but that lawyer signed this thing. That lawyer got this barred. So here's what I'll say. When you work with AI, AI will never sign on it. They'll not take it's gonna be the human. So you have to take liability. You have to own the solution. A student who uses ChatGPT to give an answer, great. I'll get into my office and ask them, explain the answer. Unless they can explain it well, that's not their answer. So I think the future is really gonna be this working together. And that's where the things that humans are good at and should be actually in control of, including things like the people affected by the decision of machine learning should be part of it. They should, develop part of it. We're not there yet. It's going to be years, but yes.
Question over here? Yeah, just a question about large.
Hold on one second. I think the people online will need to hear you speak to the next.
Thank you. So in terms of how we teach these models, throughout history, we've had situations where science believed something, whether it's bloodletting or phrenology or spontaneous generation or whatever, and then it proves to be wrong. Do you have any thoughts on how, or have we encountered situations where the AI starts learning based on these, processes enormous amounts of data based on these wrong assumptions? Do we then need to start over at the beginning, or can we kind of tweak it? And
so, okay, two answers. The first one is garbage in, garbage out. That's what you're saying, right? So we know that. But I said there were 30,000 different LLMs generated out of OpenAI. Why do you need that many? Because lots of people don't trust it. It says, I will give you the data from which you learn, right? So I showed you, it takes all the data, which is full of crap. But if I trust a particular data set, I can train just on that. And I can even use data that's not even available in the public to teach it. It's a tool. And it's how you use the tool. Are the people affected by whatever you're doing part of the design? That's important. Are you using the right data? We have a faculty in Gozi, Dagby, and she asked a question. The word safety, so there's an application. Let's put police on the street. Okay, there's a presumption that people feel safer when there's a police. Well, that's a white male sort of, upper class, because you put a police on the street, oh, I'm safe. But go now to a place where, maybe it's African American or Latinos, they feel less safe with the police. As a matter of fact, yeah, a lot of it happens because the police is chasing them. And the question is, when you teach, you remember reinforcement learning? What is saying safe, unsafe? Well, who is deciding this? It shouldn't be the people who are from one part of society but not other. This is the inclusive aspect of designing the right AI and machine learning, if this makes sense.
Question in the front, please.
Please.
Yeah, we had a discussion before, so I'm following up on that. But basically, I guess number one, my concerns is around the data. There is a multitude of data being collected that we are not even aware of. And I guess my concern, number one, is around who is labeling the data, and the machines learn off of the data that's there. And you did a very good illustration as to a facial recognition and how that can be used, with noise and things of that nature. So I guess that's one thing around the data that is being amassed, the privacy issues around it, the implications on society. It is great to know the technological advances that we have, but where is the alignment with actual reality, practicalities on the population? I guess the other question I have are more to the point. Recently, the FT had an article around the lack of, shall you say, deep learning, because people tend to look at what's generated. This is where you should go for this information. You Google it, and this is where you go. You get the information or whatever. And it's been posited that there is a lack of deep learning, a lack of questioning the information that comes to you. So how does that play out in academic environments?
Both amazing questions. I'll answer the first one. Actually, I'll answer both of them. This is why BU created CDS. I'll just start with that, okay? We created CDS. It's not computer science. Yes, I'm a computer scientist, but I got transformed, okay? I'm a different person. My department may not even like me that much, right? That's okay, because I think about it differently, right? I mentioned the courses we teach, and I mentioned the people we hire. Now, remember, it will take years. We're not there yet. But how could universities do it right is the question when it comes to research. Now, of course, the hope is people like Stacy Dogan will have a voice in precisely deciding these points. I talked about how we include those affected by the technology in designing, labeling the data, of course. Is this safe? Well, are you asking the right people? Statistics had that problem a long time ago. It's called, you call people on their phones to ask them who they vote for. Guess what? You're missing the homeless population. And there are ways in statistics to deal with that. It's called stratified, sampling. Guess what? There are techniques, faculty working, including some at BU, who work on these new approaches. Let me, if any of you is concerned, as you should, I am. But imagine the internet in its infancy. I was lucky enough to be part of that beginning of the internet, 1995. Imagine if we judged it based on what happened in 1995. We could have been totally wrong. It's a very different world. This is less than a year old. It's going to take 10 years. We have to educate a new group. So now to your second question, which is a lack of deep learning. You are right, and that's a challenge to teachers. I said it several times. We have to up our game. So can we teach writing in the presence of, we cannot remove it, it's not going to go away. Can we teach deeply and engender these type of knowledge with this technology in place? Can we develop better technology? We can try. We have to work with the right people to do it. It's not going to be a computer scientist anymore. So I said the answer to both is CDS in a way. Thank you.
There's one more question online.
Yes, our last question is from online. Is BU looking at the economic impacts of how Gen AI will disrupt many businesses today, such as replacing jobs for customer service, entry-level analysts, finance and consulting, and transactional lawyers? We are already seeing this occur in many industries now.
Thank you for asking that question. About 3-4 weeks ago, HR at BU ran a whole day talking about generative AI in HR. Okay. And I was part of a panel, and it included people who are Actually, I was the only rep of technical person because I was talking about CDS. This is actually one of a big question. But there's always negatives, and I can go into this. So yes, there will be jobs lost. I'm not. Like any technology, I want you to think of AI as just improving efficiency. When I talked about science, I talked about instead of doing 1,000 experiments that cost you whatever, you do 3 and it works. So there's nothing to do with, right? So it's efficient. That's why it's going to catch fire, because who wants to spend more money than you should? Now, the problem is there will be victims to this, like people who lose their jobs. And the question is, well, can we retrain them? We launch an online program. Why? In data science. We're launching it actually next fall. It's because we realize with this technology, you always have to have this upskilling and reskilling all the time. The AI in 10 years is going to be very different, and the students who graduated this year are going to be. So I think the answer here is, yes, we have to change how we teach. It will take time. Don't judge the book by its cover, as in today. Wait a little bit. And the good news is that now we are starting to ask the right questions. By the way, the right question is never going to be asked by Google, Facebook, or OpenAI. It's going to be asked by universities. This is why it's so important that we do this work, right? So, yeah, it's exciting. It's challenging. Yes, people lose jobs. I think HR give you some examples of great jobs to be created. So HR, how do they hire? Say, well, here's the applications. Rank them. What if my department wants to hire 3 people? Do we think about the team part of it? Or are we hiring the best person here and here and here? AI can help us get the team that will gel together better. Now, I'm not saying we have the software yet, but that's exactly what you can do. Why? Because who's going to look at 10,000 resumes to figure out the 3 or groups of 3 that I should consider as a group? I mean, lawyers. How do you assign cases to lawyers in an office? They work together? Did they have previous? That's a data science, that's a machine learning problem. So there will be jobs lost. There will be jobs created, a lot of them, I think. And I think we are in the period where redefining tomorrow, redefining tomorrow, there will be folks who are going to suffer a little bit. I'll finish with this one thought. I had one student, we ran a workshop in January about ChatGPT in CDS, and it was open to faculty, students, and staff. And one of the students who stood up at the end, we had a nice discussion, and says, I'm graduating from BU this year. And I feel like the most unlucky person, because I graduated at a time where this is happening. None of the faculty at BU knew anything or doing anything about this. I didn't learn how to do this. What is your point? It's a great question, right? Well, I cannot tell him, come back to BU in 5 years. And the answer is, well, that's the new world order in a way. You have to continue learning. There could be ways to do this. And also, don't treat, remember the friend or foe? I think we should not think of it as a foe. It's not quite a trustworthy friend yet, but we should start working with it for the better of everybody. Thank you.
Okay, so just to close with one more comment to reinforce everything Azar has said. You can never stop innovation. You can't stop it. It's going to happen. What you can do is figure out how to make sure it has a maximum positive impact on society, and as early as possible, prevent it from having a negative impact on society. So I thank you again, Azar, for a spectacular presentation. I hope you all enjoyed it. Give him a hand. Let's get some response.
And before I go, I just want to say you're all welcome to come visit. Please do. And thank you for coming here today. And I have one last small gift I'd like to present to Erin Kleh for this wonderful opportunity. Erin, this is for you. And just to thank your wonderful family for doing this. Thank you. Thank you. Yes. And I'm happy to answer questions later.